Alright, so today we're going to talk about 7.1, factoring rational expressions and getting them to their most reduced form. The problem that I'm going to do for you here is a rather long problem, so it's in two parts, so make sure you watch both the first and the second part for this. Okay, so where we're going to start, I've written these three steps up in the top corner here. You're going to use these three steps to tackle each part, each numerator and denominator in this problem. So we're going to start with the one on the top left here, this 8x cubed minus 27. Now step one says that I'm going to look to factor out any constants that I can, but there's nothing that's common to 8 and 27, so I can't do that. But step two says to look for any special circumstances, and those are listed on page 340. Now this little cube here gives me sort of a clue as to a special property that might be involved here. Specifically, the difference of two cubes is what we're going to work with. So, I want to rewrite this expression into something cubed minus something cubed. Now, if you ask yourself, what cubed makes 27? Well, if you work backwards, you'll figure out that it's 3. Because 3 times 3 is 9, times another 3 is 27. This term over here might be a little bit trickier, but you can break it down into pieces. First, we know with this x term that x cubed will give us x cubed, so we know that part of it is just x. Now, we're going to look at this constant. What cubed gives us 8? Well, that happens to be 2. 2 times 2 is 4, times another 2 is 8. Okay, so now I have my expression written as something cubed minus something else cubed. And I'm going to use this formula. Now note, your book uses x's and y's, which I'm not a big fan of because this problem has x's in it, so I think that's a little more confusing. So I'm going to write it in this form. Oops, that should be a 3. So a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Now the reason that I have to break this down is because this term on the inside of the parentheses, that's what a is. The term on the inside of this parentheses is b. So I now have something a cubed, b cubed. So I'm going to rewrite this expression here, substituting my 2x and my 3 for a and b. Okay, so this is now 2x minus 3 times, use parentheses here, 2x, the whole thing, squared, plus 2x times 3 plus 3 squared. Now if I break this down a little bit further, I have 4x squared plus 6x plus 9 in these parentheses. Okay, so 8x cubed minus 27 factors out to 2x minus 3 times 4x squared plus 6x plus 9. Okay, so I'm going to leave that alone for now. I'm going to move to the second part of my equation here, the denominator of the first term. So I've got 2x squared minus 18. Okay, and again, the first step that you look for is to factor out any constants that you have. Well, as it turns out, 2 goes into both the first term and the second term. Right, 18 you can break down to 2 times 9. So we can rewrite that as 2 times x squared minus 9. And now I'm going to look for any special circumstances. Well, x squared minus 9 is a difference of two cubes. So the difference of two cubes formula, again I'm using a's and b's, your book uses x's and y's, says that a squared minus b squared is equal to a plus b times a minus b. So I again have to put these in terms of a and b. So I have to ask myself, okay, what squared gives me x squared, and what squared gives me 9? Well, what squared gives me x squared is pretty straightforward. That's just x. What squared gives me 9? Well, 3 times 3 is 9, so 3 squared gives me 9. So that's my a. X is a. 3 is b. I'm going to plug that into my formula over here, and that will give me x plus 3 times x minus 3. Okay? And like I said, this is a long problem, so I'm stopping here, and we'll be continuing on in part 2.